Good afternoon, and welcome to the Open Systems Media webcast, Industrial IoT Security, the OT Infrastructure Shift. My name is Rich Nass, and I am the Executive Vice President of Open Systems Media, and I lead the embedded and IoT teams for embedded computing design. But more importantly, I will be your moderator for this webcast. On the webcast today, you'll be hearing from two speakers. You'll first hear from Jeff Bates, and he's a product marketing director for PTC. And then you'll hear Nihir Patel. He is a product manager for Real-Time Innovations, also known as RTI. Let me tell you a little bit about each of the speakers. First, Jeff Bates leads the product marketing for PTC's portfolio of ThingWorx and Kepware products. In that role, he works closely with end users and partners and industry experts to develop relevant, up-to-date messaging on the value of the company's connectivity solution. And then Nihir Patel has more than 11 years of experience in embedded software and distributed systems. And in previous roles, he led safety certification efforts and worked with external partners to launch a cross-company project to build a small footprint RTOS for IoT that uses security-minded development practices. Okay, so before we get into the webcast, let me explain you what you'll be hearing and what you can expect to hear on the webcast today. It is not really any revelation that current security systems have to change. The number of breaches is on the way up, in spite of the emphasis that the industry seems to be putting on security. We have firewalls, air gaps, antivirus, and all that kind of stuff, but these hacks are still happening. What are you supposed to do as a developer? Well, I'm glad you asked, because that's exactly what you'll learn over the next hour. So stick around, because this is going to be a great webcast. Before we start the webcast, let me just go over the housekeeping stuff real quick. This entire presentation will take about 45 minutes, give or take a few minutes, and that'll leave us plenty of time to answer your questions, and we will get to as many as time permits. You'll find down the console window an area where you can enter those questions in real time. And as I said, we'll address as many as we can when the two speakers are done with their presentations. If your question does not get answered, if we run out of time, someone will get back to you after the webcast with an answer. So everything will get answered. If you have a question pertaining to the webcast operation, like if the slides aren't advancing or there's an issue with the audio, put that question into the console, and one of the technicians will respond back to you with what you need to do. There's also a maximize button on the console that allows you to see your slides in a larger window. And also note that this webcast will be available in an archived version about 48 hours after we sign off today. So if you miss something, or if you want to go back and review or send it to a friend, it will be there for you. So without any further ado, here's Jeff. Take it away, Jeff.
Great. Thank you very much. So my name is Jeff Bates. As Rich said, I'm a director of product marketing at PTC, and I focus on the Kepware and ThingWorx technologies. I want to thank everyone again for joining. Security is a very important topic for both PTC and especially for Kepware. And I do want to start by just saying that Kepware is not a security company. We don't offer security services, and our products are not security products. But we are constantly exposed to industrial control system or OT environments. So we do bring a perspective here, and we feel it's important to promote that perspective, especially given the current threat landscape. To sort of further introduce the structure of this webinar, we really, at PTC, we break down the market into smart connected operations and smart connected products. With regard to smart connected operations, that is the idea of I'm running a factory and I want to connect the factory floor to make my production more efficient or safer. And smart connected products is I am shipping a product and I want to connect it to better service or design that product or have a better customer experience. Each of those markets are unique markets. Those are two separate use cases, and each of them has unique security concerns. So today we're really bringing two different perspectives. I will first cover the Kepware's stance on security from a smart connected operations perspective, and then I will pass it off to Nahir, who will cover RTI's perspective on smart connected products. So first, let me just introduce Kepware and talk a little bit about how we end up in these environments. So first, let me say again, Kepware, not a security company. We are exclusively focused on industrial connectivity. Plants are by nature heterogeneous environments, and there are many devices in the plant that utilize proprietary protocols. Many customers are implementing software such as SCADA or MES or HMI or historians in order to improve their processes. And connecting those applications to heterogeneous devices within the plant can be difficult. And so Kepware's really reason for being, the problem we're trying to solve, is to alleviate the interoperability problems when implementing those types of solutions. We work in the industries that you see listed here, and we are part of the PTC portfolio of products, which really all focus on connecting the digital and physical worlds. And so how do we do this? We are a connectivity, or KepServer EX is our flagship product, and it's a connectivity server that connects PLCs, CNC machines, sensors, other industrial assets to digital solutions such as SCADA, HMI, MES, and the industrial Internet of Things. That's really the major purpose of the product. The differentiator is around reliability. Reliability is critical in any operational environment, and Kepware and KepServer EX have been successful via a relentless focus on reliability. When we ask our customers why they choose KepServer EX, the answer is always that it just works. So that's where we get exposed to this world. That's where we're deployed into operational environments. Again, we're not cybersecurity experts, but we do play in this space. And because we play in this space, and in some of these, as you saw in the industries covered, a lot of these spaces are designated as critical infrastructure. So security is very important to us, and we pay close attention and feel that we have an important responsibility as a component of that ecosystem. So we do have a perspective on where we see these environments today. So I'll go through and talk about what we see as the current state. And obviously there's a mix of companies and how advanced they are in their security posture. But what we see a lot and what we're exposed to a lot is really a focus on perimeter security and network segmentation. So this is, Rich mentioned the air gap. As many of you likely know, the ICS network is usually segmented off from the enterprise network. Some are actually air gap, there's no connection, but usually companies refer to their operations network as being air gapped, even if there are connections between the operations network and the enterprise network. And this is really what many companies today still rely on, air gapping and physical security. And it creates situations where many companies have a server, and we see this time and time again. It sounds maybe crazy, but we see situations where many companies have a server or a machine on the plant floor with just a single admin account on it, and the admin password on a sticky note attached to the device. One customer joked, or one system integrator joked with us that, if security is really tight, then the sticky note will be, in a drawer attached to the underside of the table, or something along those lines. And the logic behind this is, well, if anybody gets to this computer, we've failed from a perimeter security perspective. So security mechanisms on the server itself are useless. And obviously, there is a range of companies, again, as I said, that think differently, that have more advanced security postures. But in our conversations with customers and talking to system integrators, we find that this viewpoint is still pervasive. And just in a little bit of foreshadowing, I mentioned that air gaps are, it's always called an air gap, but as you can see here, it's a little bit of a misnomer, as there's generally always a connection between the two networks. Similarly, in the industry, we often see a lack of a plan or a system or a process around upgrading. And you can see how this has happened over time. Given the cost of downtime, if a process is working, why would you touch it? Why would you risk downtime when downtime is measured in hundreds of thousands, if not millions of dollars an hour, by upgrading an operating system or adding a patch to a piece of software? Factories, as many of you know, are full of processes that are 10 or 20 or 30 years old, that they've been running for that long. And these processes are often validated, and revalidation can be absolutely brutal, sometimes 3 to 6 months. I've talked to engineers who say, this is not even a very big part of my job, but it is hands down my least favorite part of the job. And just to give a little bit of data around this fact, this is actually, on the left-hand side, is data around our application. It shows the percentage of our customers who have at least one instance of KEP Server EX in each of the categories listed. So that you can see that only 40% of our customers even have one instance of the software that's on its most recent version. If you look to the third column here, or the third bar, almost 50% of the customers are using a version that's over 4 years old. And we actually have a little over 10% of customers that have at least one instance of a version that is over 10 years old. And based on our experience, this is not unique to KEP Server EX. This applies to operating systems, this applies to SCADA systems, this applies to a wide variety of systems found throughout the plant. XP is still widely used, and it's certainly not the oldest operating system that is in use. So there's much more to dive into in terms of what is the current landscape, but that's a brief snapshot of the current state. Again, many organizations are more advanced than that, but this type of thinking is fairly prevalent based on our experience. And so the question is, how comfortable should we really be with that present reality based on the threat landscape? And I think that you'll see the answer is not comfortable. And the reason for that is, one, that air gap, the all-important, all-saving air gap is really a myth. A branch of the government, U.S. government, went out and found that on average there are 11 connections between the operations network and the enterprise network. So relying on that as a security measure is very much not sufficient. And then you can see that the threat landscape is evolving, and the threat actors are taking advantage of the poor security in this space. There's been a 110% increase in cyber attacks on ICS networks from 2015 to 2016, and well over the majority of organizations are affected. And the consequences of these attacks are real. To date, they've been mostly targeted at the financial side of things, where you are looking at loss of IP or downtime that keeps you from producing, but there is a real possibility for compromised safety, either at the individual level within a factory or even at a larger scale. When you start talking about the Ukraine power outages in cold weather, and there was also recently an example of a dam that was hacked, and the only saving grace is that it was offline for maintenance at the time. Here are a couple of examples, a couple of concrete examples. Obviously, there are many, many more and plenty that do not get reported. But I've highlighted the protocol that gets attacked because they're all, in general, these are very old protocols that don't have adequate security measures. And the fact is that there are newer, more secure protocols that exist, and we'll talk about those. But because systems don't get upgraded, the existing systems use old protocols which are really inherently vulnerable and difficult to secure. I'll do a little bit of a deeper dive on one example called the HAVEX attack. And per the comment around the importance of secure protocols, which I know Nahir will also touch on, HAVEX was an attack on OPCDA. And OPCDA has a feature which allows a user, in most cases a user, to browse the tag structure in an enterprise, the data tagging structure, which generally can give you very good insight into how the plan is designed. And in this case, it wasn't a user, it was an attacker who was able to get that insight, which is really the IP of the factory. And it had a very wide blast radius, around 2,000 sites across the industries, or excuse me, geographies that you see here. So hopefully this has painted a bit of a picture of the problem, antiquated security methodologies and a changing threat landscape where the landscape is changing quicker than organizations are reacting. So we'll talk about a little bit about some of the simple things that organizations can do. These are very simple, or they start very simple and get a little more advanced. But again, this is Kepware's perspective on this. We've worked with a number of experts on this subject that I'll mention in the subsequent slides. So we've picked up a couple of these best practices, but really these are security recommendations from a Kepware perspective to get recommendations and to find the lowest hanging fruit within your organization. It's critical that organizations work with system integrators and other experts in security. But again, we've been able to pick up a couple of best practices on the way. Again, I'll start with the most basic. And probably not surprising to anyone, the first and foremost recommendation is to upgrade and patch. I think I've kind of painted a picture of it already, but to drive the point home, security is an arms race. Software that was released with even the most advanced security features of 2 to 3 years ago is likely today to already be vulnerable if it's left unpatched. The encryption breaking technology continues apace, and if you leave the security where it was 2 or 3 years ago, or even less, that software becomes vulnerable. And I'm certainly not discounting that this is difficult to do, especially in a system that is validated. But I will say that I've talked to companies who've been proactive on this front and started to come up with a process and a testing process for revalidation in order to enable a quick upgrade of OSs and software components. And I've also talked to customers who have only implemented those processes after an attack. And suffice to say, without getting too far into it, you certainly want to be in the former group. You want to be proactive versus having to be reactive. Also, this upgrading and patching and having a system for that has been defined as a best practice by ICS CERT. So essentially, the major takeaway is that the risk of not patching outweighs the risk to operations from patching. So second is password management. Just to kind of call back to the example of having a sticky note on the server. Come up with a system for strong passwords and storing those passwords that doesn't inhibit operators from doing the work that needs to get done, but is significantly more secure than just essentially leaving it wide open. So these are two very basic recommendations that are sort of no-brainers. There's probably a ton of low-hanging fruit within your organization, and that's why it's so important to be working with an expert to identify and implement them. As an organization, you can either hire someone with ICS security expertise, there's probably enough to do in your factory around ICS security that it's worth the cost of having someone in-house. And then there's plenty of services firms, system integrators that offer these services. Rockwell and Red Trident are two that we've worked with in the past, but there are many, many others out there. So those are very basic recommendations. I also want to talk about how can KEP-Server-EX be used to enhance the security in an ICS network. And one of those is tunneling. There are, as I said, many factories today that are using OPCDA to connect their assets to SCADA systems or other manufacturing software. And as a manufacturer, this may even be the case in your factory. You may be worried about it. You may say, listen, I realize that OPCDA is inherently more difficult to secure, but I don't have the budget to do a full upgrade of my SCADA system. I don't even have the budget to do a switch over on my existing SCADA system, most of which offer OPC UA today. And so essentially, you may be in a situation where you need to retrofit an existing system and make do with what you have. You don't have the budget. Everyone would love to have shiny new machines that all speak OPC UA, but the fact of the matter is that without ripping and replacing, essentially ripping and replacing is prohibitively expensive, and this happens all the time in a factory. So one of the things you can do is to add an OPC UA tunnel. As many of you likely know, OPC UA has much more robust security than OPCDA, and just by introducing an additional instance of KEP-Server-EX into an existing environment, you can utilize OPC UA to traverse a network versus OPCDA. And that's illustrated here on the right-hand side, where the OPC UA is being used to traverse the network, and then that extra version or that new version of KEP-Server-EX is communicating over DA on the local host, so that you're not changing the way that you're communicating with your applications, but you are reducing the attack surface over the network. So to learn more about OPC UA and its security functions, the best place to do that is at the OPC Foundation's website. And if you want to learn more about this specific application and how to implement it, you can go to kepware.com, and we've got a link to our tunneling solution right on the homepage. So another way to utilize KEP-Server-EX to enhance plant security is using the Security Policies plugin. It's included with every installation of KEP-Server-EX, and it allows you to control which tags are visible to which client applications. So as many of you likely know, but for those of you who aren't familiar, KEP-Server-EX, a single instance of KEP-Server-EX can connect to multiple client applications. So in this example here that you see on the right-hand side of the slide, you've got the server connected to a SCADA system, a database, and an industrial IoT solution. And all of those solutions need to be able to read from a certain set of tags. And maybe you want the SCADA solution to have read-write access to be able to do some control for a certain number of tags and only need read access for other tags. In the database, you really only need read-only access on the tags, on all of the tags. And then in the industrial IoT solution, you really only want that application to be able to access certain tags, and you want them to only have read-only access. And that's possible with the Security Policies plugin. You can set up access at a very granular level. You can set it up at a device level or a channel level, but you can also go down to the very granular tag level and set permissions on each individual tag. And that also applies to configuration. If you have two different users who you want to have different configuration privileges, you can set that up in Security Policies plugin as well. So those are a couple ways that you can use, potentially if you're already a KEP-Server-EX customer, you can use what exists today just by what you have, or either by upgrading to the most recent version of the the software, which we hope you do, and you can use those tools to enhance the security of your existing ecosystem. Again, the real work needs to be done with an expert, either one that's hired internally or a system integrator or services firm. But we did want to get this information out. We do believe that we have a shared responsibility to make sure that these environments are secure. So I appreciate everyone taking the time to attend today. I will now transition from the smart connected operations side of things over to the smart connected products, and I will pass it off to Nahir at RTI.
Thanks, Jeff, and thanks everyone for your time today. Let's go ahead and get into this. I'm going to go through a very similar format to what Jeff went through, but as he mentioned, I'm going to go from the smart product side of things. We'll talk a little bit about what RTI is, what we do, and dig into the trends we're seeing. And from there, we'll talk a little bit about DDS security, so it's Data Distribution Security Standard, and really look at it in the light of what are the considerations to make when you're building these smart products. And again, we'll get into what type of products those are. So I'll start with looking at RTI. We're kind of a medium-sized company, but we've got a global footprint. We're a leader in connectivity, but connectivity more in the edge, embedded distributed systems. So we're in a lot of mission-critical systems. There's critical infrastructure. There's military defense applications. And with this concept of autonomous systems, there's the really cool and sexy industry of autonomous vehicles, so self-driving cars. And we're going to dig into that one a little bit more here. Again, we really lead on the connectivity side. So as similar to what Jeff was saying about PTC and what he's doing there is we're focusing on connectivity, but we apply best practice security measures. We leverage commercially available and validated security technologies and apply it to this world of connectivity. So in a minute, I'll talk a little bit more about the shift we're seeing, but I wanted to just introduce, for those of you who are not familiar, Data Distribution Service is a publish and subscribe technology and really a framework built around a protocol called real-time publish and subscribe. So what we can build with those systems, or with that technology, are the systems you see here, and with a focus on the industries that you see in front of you. There's applications in autonomy or just machine intelligence across the board, and we're seeing that we can make the biggest impact in transportation, healthcare, energy has a lot of potential, and of course, aerospace and defense. So let's dig into this idea of autonomy. We've seen this evolution starting to play out where there are all these devices and they start getting connected. They get connected up to cloud systems, and now you can monitor things like your home, you can monitor your factories, you can monitor all these different systems. But as software becomes much more sophisticated and as networking becomes much more powerful, we're seeing this drive towards autonomy, right? And we might be more in this optimization phase, but we're seeing, I'm in Silicon Valley, I look out the door and I see these self-driving cars every day, and I have to close my eyes and look away if I'm going to avoid one. So these things are everywhere, and we're really focusing on enabling that autonomy and that autonomy at the edge, right? So where real-time performance, where you're taking what were traditionally closed systems and really putting them out there in the public to be used and to run. And that's where we're going to start to see where security from our perspective comes into play. So just another quick look at this from an architectural perspective. a lot of people originally would think of IoT as this idea of I have a device and it connects directly to a cloud system, some server, a computer running in a data center, and there is a set of technologies that enable that and established security practices that enable that. And this is an architecture that's going to exist, right? Going forward, it's not something that's going away, but what we're seeing that's evolving in order to enable autonomy is this idea of kind of the east-west device-to-device communications, so intelligent decisions can be made at the edge without having to first go to a hugely powerful data center, right? But then when we start connecting those devices at the edge, when we start pumping them with data that's available outside of that particular network, that's where we start to see the challenges arise. So let's take the example of the autonomous vehicle. So this is the architecture we see that's evolving in the world of self-driving cars. There's a place for legacy systems, typically managed by a CAN bus, and we would have some level of interoperability with that type of technology, and then we would connect up to growing technologies like AUTOSAR Adaptive, still yet to be defined and developed and implemented technologies around data fusion and autonomous driving and AI, and we think about the sheer amount of data going back and forth across these systems. It's just impossible to get it up to that cloud service to get back down with an intelligent decision. So all that's going to be happening at the edge, and all that data is, presumably all that data is incredibly sensitive, and there might be variations in levels of sensitivity that we'd address, and that we'll talk about in a minute as well. But as you can see, there's still that place to connect up to servers or cloud systems where there is a level of monitoring, right? So it's an evolution of the systems we see today. Okay, so we're here to talk about security. We jump in, and there are these different ways of viewing security. Traditionally, vehicles, very closed network, not a whole lot. So this idea of the system edge applies. There are other ways of securing your trusted compute base. The network, TLS, is very popular, DTLS for a lot of industrial systems. Where DDS security and data distribution services comes into play is really around the data and the data flows between all these interconnected systems, right? And what this allows for is a level of trade-off between performance and security, a trade-off in levels of security, computer usage, things like that. Now, a caveat here. There's no silver bullet in security, and I think Jeff would agree, right? Is you have to look and architect your system, and you have to think about what works for you. And what DDS security does is it comes in as a complementary player in a slew of solutions, a slew of security technologies that you can apply, or connectivity technologies that you can apply to secure your particular architecture, right? So security can be very personal in that regards. Is what is it that matters the most to you, to your teams, to your company, to your stakeholders, and this is another weapon in your arsenal against unwanted threats. So I'm going to take a deep dive at this point, and I'm going to look at some different components of what DDS security offers. But I want you to keep in mind that picture of the vehicle, and I'll show it just one more time. It's imagine the self-driving car. It has all these components. You're sitting inside, and what are the things that are happening behind the scenes? And let's dig into that. So let's start with network bandwidth, right? In the vehicle itself, you're going to have a limited amount of bandwidth, and this will apply to any kind of embedded distributed system. You're going to be fighting requirements, functional, performance, security, safety in many cases. So let's start with that. We could apply something like TLS for point-to-point communication between all these different systems, but then, for every one device, you may be sending the same data to multiple recipients. And then to encrypt that individually and then send it, you're going to be using up, those are messages on the network, right? And that's gonna eat up bandwidth. And actually, it'll eat up the compute cycles as well. But if we take a data-centric approach, we could secure the data once and then send that 3 times if we wish over the network, and that's okay. Again, depends on your requirements. But we can take it a step further, and you can use multicast and save on that bandwidth altogether, and you're still saving on CPU cycles. So now you can start to get an idea where you can shape your network and secure the data with performance without compromising performance or any of your other functional requirements. Right? So the real takeaway from this particular example is how do you want to apply security to your network so that you can deliver on really tough requirements for your end customer. And then we're going to do this again, right? There's another idea of getting into fine-grained topic-based protection. So I have one device, maybe my trip planning system in my vehicle is sending multiple types of information. So I might have a single application that's publishing 3 different types of data. Well, it may be the case that we want to protect all the data, and that's fine. But it may be the case that some of the data, maybe it's wind speed, air temperature, whatever, it's not so sensitive that I have to encrypt it. In which case, what I might do is just single that one out and authenticate it. Right. So I can now use this idea of fine-grained security to choose between encrypting sensitive data, encrypting and authenticating sensitive data, or I can just authenticate the data so I can establish this data integrity and then proceed with my operations. Digging a little bit more into fine-grained security. Now let's how can we minimize the packet sizes, the data that's going to go from my trip planning system to my vehicle drive, or just making sure that my vehicle drive system has enough processing capability to operate without compromising the safety of the passengers. We can start looking at the packet itself. With TLS, we'll encrypt the TCP packet and authenticate the TCP packet. And again, that's fine for the non-mission critical, non-real-time. Maybe it's business critical, but non-real-time systems. But here, this is the RTPS packet, and you can see there's some sub-messages there. This is actually encapsulated in typically a UDP packet, so it's much smaller, and we can choose to encrypt the whole body, right? So that's the choice that you get to make, and we would encrypt it using best practices like an AES 256 GCM, for example, or again your choice depending on your requirements. RTI isn't going to, and Connect's DDS Secure isn't going to dictate the algorithms you use. It would simply provide you access to those algorithms. But let's take this a step further, right? We can actually go in and encrypt parts of that packet. So the total packet size going on the wire is actually quite small, and only the parts that are critical for protection. Again, the takeaway from this is not, this is necessarily the right exact thing that you should be using. This is the trade-off, the considerations you make when you're building these autonomous systems, these smart systems that need to be able to operate at very high speeds with very low latency, and you simply have to make the trade-offs. There's no other way other than spending maybe more money on bigger computers. I'm going to touch on one more element here, and that's this idea of, we're taking these closed systems and we're putting them out into the world. So how do they discover each other? Because presumably, if multiple automotive manufacturers are, producing vehicles and they somehow need to talk to each other, how do they know each other exists, right? So there's this idea of discovery. These systems discover each other in real time, and as part of that, they need to have a method of trusting each other or not trusting each other, as the case may be. And so this is where the idea of perfect forward secrecy comes in. And again, right, RTI doesn't implement algorithms for perfect forward secrecy. We leverage something like elliptic curve Diffie-Hellman to establish that, but we take advantage of that in a data-centric way. So I don't expect folks to follow this whole chart, and certainly I'm happy to go through it with folks individually outside of this webinar. But from top to bottom, there's a series of activities to discover a remote participant on a network and authenticate and access, determine access privileges with that participant. And along the way, we'll use those best practices, right? So we'll do the mutual authentication with elliptic curve Diffie-Hellman. We'll establish a shared secret that can be used instead of the asymmetric keys that would otherwise provide proof of identity for a participant on a network. And then we can start to communicate very efficiently with these symmetric keys. Okay. So, again, the takeaway here is how do you establish the trust? What are you using to establish trust? The best practices out there, there are best practices established out there, and I would argue that you would want to look for vendors who are taking advantage of those as opposed to necessarily developing their own proprietary standards. So we at RTI have a value in open standards, a value in leveraging best practices, and arguably the best solutions out there will do the same. Okay. Just to tie this back up, we're looking to build this autonomous vehicle. And I say we, it's the collective we. The autonomous vehicle, the autonomous ships, just anything with artificial intelligence, anything with any sense of autonomy. We're going to find that there's going to be a lot of data being passed around at the edge, and that edge had typically been closed to the world and now is being open, right? Is collecting data from public networks or over public networks, is having to connect to systems that come from other companies that you may have to worry about IP protection, you may have to worry about the protection of privacy protection of maybe passengers, for example. So really taking a look at how you're applying security at this embedded level, and not necessarily just relying on traditional security practices, but taking those security practices and applying them to these distributed embedded systems. So thank you for the time, everyone. Rich, back to you.
So that would be back to me. Thank you very much, and thanks both of you for some great presentations. Okay, so we have about 15 minutes here. Wow, you guys are right on it. You said 45 minutes, and you are 45 minutes. That's pretty impressive. Okay, let's see. Let's start with these questions. And unfortunately, I have to put my glasses on these days to read these questions. Okay, first question. Looks like this is for Jeff. Does UA tunneling require a separate KEP server license which functions as an OPCDA client on the device side and OPC UA server on the client side?
Yeah, great question. Let me get back to that slide. So an OPC DA client to an OPC UA client. So no, there's only if you look at this slide in the right-hand side of it, there's only one additional instance of KEP server that's required. And so if you look at the setup in the middle here, you've got a device communicating. Say you're just communicating to a PLC. And then that's connected to KEP server, and then it's communicating over DA to a SCADA system or HMI or what have you, or MES. So the security gap here is that you are in this diagram and in this conversation, I'm assuming, and in many cases it's true, that the SCADA system is on another box, on another server, and you need to traverse the network with OPCDA, which also I'm glad somebody asked about this, because it also requires you to set up DCOM, which anybody who is familiar knows is a pain, and anyone who isn't familiar should count themselves lucky. So that's the security hole. And then by implementing another instance of KEP Server React with another license of KEP Server React, what you can do is, instead of on the server on the bottom represents the same server, but now instead of communicating over DA, it's communicating over UA, which is then connected to this other instance of KEP Server React. And then that instance is again communicating to the application using OPC DA, so that application is none the wiser, but you have removed the attack surface of DA traversing a network and have replaced that with OPC UA, which, I mean, here you can't emphasize that point enough, that using standard and best-in-class practices like OPC UA does is just critical. So that's the benefit, is now you're over the network, you're communicating over OPC UA, which has all of these associated security benefits. So hopefully that answers the question.
Excellent. Okay, next question. Does complexity of encryption decryption have impact on hard real-time system performance?
Yeah, I can address that one. Yeah, there is an impact, and really it goes to when we talk about hard real time, we're really looking at the determinism. But to a degree, I believe that question's also pointing at the performance impact, and yeah. Earlier I touched on, we're talking about autonomous vehicles, so safety is important there as well. What we've seen is, there's software cryptography that, has hardware acceleration support that typically can help maintain that real-time aspect. But there's a lot of hardware-based cryptography that would effectively provide that hard real-time aspect. And we'll find that from a real-time perspective, the real wild card is the artificial intelligence. It's not clear how something like that can be established. How do we protect the artificial intelligence piece, since it's all, not static algorithms anymore.
Okay. Next question. This is probably for Jeff. Is KEP server platform agnostic?
No. So KEP Server EX is based on the Windows operating system. You can see the supported operating systems right on the website. I guess I'll just say today we do not have a Linux-based offering.
Okay. For Nahir, how would blockchain technology assist in any way?
Well, that's a great question, and certainly one that a lot of my colleagues would love to chat about all day for several days in a row. We can look at the ledger technology of blockchain to effectively track transactions, interactions, or contracts, if you will, between some of these devices and agreements that these devices make amongst themselves in an intelligent way. So there's concepts of non-repudiation or furthering the idea of protecting data through some of these technologies. As far as kind of the broader reaching impact, that's certainly something we can talk about with several colleagues that have looked into blockchain in much more depth than I have.
Okay. Let's see. Next one for Jeff. Is DDS operating with the TCP/IP stack, and if so, what layers?
Yeah, that's actually that's a question for here.
Yeah, I'll happy to field it.
I'm sorry.
That's okay. Jeff, we look a lot alike, so. So DDS is transport agnostic. It actually operates at the application level. So it is effectively a software library that is integrated with the device application. So we're agnostic to the underlying transport. So TCP, UDP, and then even extending that, we're agnostic to the medium. If it's Ethernet, fiber, serial, Wi-Fi, that's all. Regardless of those technologies, DDS could be used in these systems.
Okay, Jeff, this one's really for you. Is KEP Server available for experimental purposes, such as creating a small edge device?
Yeah, absolutely. So one of the great things about KEP Server is that we call it a demo download, but the product is available. It's really the full product that can be downloaded from our website. It's got the full functionality. The product in demo or in time limited mode works on a 2-hour time limited function, but it's not like 2 hours and then you're done. You can just restart the runtime. So certainly, any experimentation that you want to do, dropping it in an edge device and experimenting with different architectures, we absolutely encourage that.
Very good. Has OPC UA over DDS been tested? If so, at what scale and what scan rate?
I think I can at least start to address this. We've actually looked into more, not quite DDS over OPC UA, but rather the interoperability between DDS and OPC UA. So at this point, we've done proofs of concepts and some demonstrations at various conferences like Hanover Messe, where there's application meets process automation. So as far as kind of the fundamentals there, I'm happy to chat with whoever that is offline, because I need to pull in some colleagues that have more details. Don't quite have that on hand. But also would be interested in hearing thoughts about why DDS on top of OPC UA would be interesting, as opposed to maybe interoperating together, where OPC UA might be used for that commanding and manipulation of PLCs, and DDS would interoperate with that and maybe integrate the intelligent applications. Integrate the software applications for the machine intelligence portion of that.
Okay. Jeff, I think this might be sort of a follow-on to what you said before. The person is asking application layer, meaning within KEPware. Were you addressing the application layer?
Sorry, I'm not following that. The application I guess in the tunnel.
Were you referring to the
tunneling
application layer within Kepware?
So the application layer protocol in the tunneling is you're essentially changing that from OPC UA to OPCTA to OPC UA, and you're still using the same transport layer. I'm not sure if I answered that question.
Nahir, I think that was actually for you. Now that we're hearing, do you know the answer to that? Okay, let's move on.
Oh, sorry. No, sorry. I was just rereading that. When I refer to application layer, it's it's the traditional OSI model, not specific to what PTC offers, but application in the sense of an application that any embedded developer or distributed system developer would architect. So it's that general application layer. Generically, right?
There we go. Mystery solved.
Yep.
Okay.
Thank you.
Okay, Nahir, stay with it. Is the data flow security provided by DDS secure enough, or do we need to augment it with other forms of security?
So great question, and absolutely you need to augment it. What we do and where we focus is protecting the data. Now, if you've established that you trust your host, you trust your private keys are safe and your certificates are valid, then certainly you can make that decision. But our recommendation is, take a look at your architecture, see where your vulnerabilities, or not vulnerabilities, but where the threats lie for your system, and work with folks like RTI to determine what other technologies you need to really protect your data. Without going too much into depth, there's a whole, we do 4-hour seminars on what DDS security can do, but roughly we look and protect data on the network. There's always, the PKI piece of this, the certificate management, those are all prerequisites to using DDS security, and we have partners in our ecosystem that can help solve those problems, but those are technologies that should be addressed. And some of our customers, they use, again, commercial solutions for this, or they may use something like an OpenSSL and do self-management. Again, that's dependent on system requirements and security requirements.
Okay. Next one, and we're getting up to the top of the hour, so we're almost at the end here. This one's a little bit of a crystal ball question, and it's for both of you. Once OPC UA, and I'll paraphrase, becomes a widely used standard, do you believe that future attacks will be targeted at this protocol?
Jeff, you want to go first?
Sure. I think, without having a crystal ball, I think one of the reasons to be optimistic about OPC UA versus OPCDA is just how much is really around what Nahir said, where it's so much easier to get the security right and to use modern encryption and hashing algorithms on OPC UA versus getting OPC DA and DCOM set up correctly. It's almost, it's not insecure, but it is very difficult to set up securely. So do I think that people will attack OPC UA? Yes, absolutely. That seems like the threat landscape is leaning in that direction. But I also know that the OPC Foundation has dedicated and continues to work on hardening and using new but best in class and standard algorithms to secure the protocol. So they're constantly adding new security profiles which are robust against modern attacks.
And I agree with everything Jeff just said, and I'll just quickly add from a bit of a different perspective is, where is that protocol being used? Because the higher value system it is in, typically the sweeter the pie for someone to want to attack it. So if we think of it more from a kind of a monetary aspect or value aspect, then certainly, yeah, it's going to be a ripe target.
Very good. Well, I'm afraid we are out of time. Let's see what we got here. As a final reminder, all Open Systems Media webcasts are copyrighted and may not be recorded without prior permission. I'd like to thank Jeff and Nahir for their great presentations, and I'd also like to thank PTC and RTI for sponsoring this event. And of course, we'd never be able to do any of these things without you, the engineer. So thank you all for attending, and have a great day.